Welcome to the third segment of lecture 6. This is Mirza, Tanjim, Shorif, Muggdho, and today we'll be practicing a few problems. So in our last segment of the lecture, we have seen how to approach the same problem from different perspectives. Okay, so you might be asking, what is the point of solving the same problem using so many techniques? It's such a waste of time, right? No, it isn't, because there were some techniques that's gonna turn out to be the only way to solve a few upcoming problems. So let's start. Our first problem states that suppose there are 1000 students in department of CSE BRAC. 750 of the students completed CSE230, 450 of them completed STAT 201, and 350 of them completed both of the courses. The question also says that there are n students who completed none of the courses. So the question you're supposed to answer is, if a student is randomly picked from the department, what is the probability that she or he completed at least one of these courses? Okay, so she might have completed CSE 230 or STAT 201 or both of the courses. All right, so this is pretty much the same problem as our last one from the last segment. So I hope you can solve it. The question number 2 asks, what is the value of n? That means, what is the number of students who completed neither of the courses? Okay, so you're given with a hint here. So you're supposed to use inclusion exclusion principle from our set theory, and you can also take help from Venn diagram. Okay, so when you are drawing a Venn diagram, a rectangle representing a sample space, circles representing two different events, if there's overlapping, then you know that these events are not disjoint. Figure like that would give you a better insight to solve the problem. All right, so this is the question number 2. Question number 3 is an optional challenge. This is the question for those of you who want to brainstorm a bit more. The question states that if you choose two students together at random, what is the probability that both of them completed CSE 230? Here's the hint for you. The probability is defined to be the fraction where the numerator is the number of total favorable cases and the denominator is the number of total cases. All right, so you are going to determine in how many ways you can choose two students from 1000 students of Department of CSE, and then you are going to find out in how many ways two students can be chosen from the students who completed CSE 230. All right, and then just dividing will give you the answer. I hope I just have solved this problem for you, but try it yourself. Problem number 2. In this question, it states that if a coin is flipped 7 times, what is the probability that it shows tail every time? Okay, so you're flipping a coin for 7 times. The first question asks you to determine the probability that it shows tail every time. So all 7 times you want tail to come. Okay, all these 7 events are independent of each other. It will help you with vital information that will help you to solve this problem. So the question number 2 states that what is the probability that it shows the same side every time? Okay, so yeah, either all of the results are head or all of the results are tail. There would be 2 different cases, so you need to find out both of the probabilities and then finally add to get your final result. The third question asks you that what is the probability that the results it shows alternate? That means if the first time it shows a head, the second would be tail, the third would be head, the fourth would be tail, and so on. Okay, and this problem also has 2 different cases. One will start with a head, the other will start with a tail. Okay, then you are going to find the probability for both of the cases, and then again you're going to add them. The fourth question asks you, what is the probability that the coin shows at most 6 heads? All right, so out of these 7 times, at most 6 head are expected. So what is the probability of that? You are going to use your idea of at least here, and the hint for this problem would be calculating the complementary case. Okay, the probability of our unexpected event and then subtracting its probability from 1. Okay. Now, the question number 5 is again an optional challenge. Here we asked that find the probability that it shows exactly 5 tails. So you are flipping the coin 7 times and exactly 5 of the times you are expecting tail. So ultimately the rest of the times you are expecting head. So you'd need your combinatorics idea for solving the last question. Now we are going to solve a card problem. So in order to solve this problem, we have to introduce ourselves with the cards. Okay, so let's introduce ourselves. I know many of you have already played cards, some of you didn't. So for those who didn't play card, it's for you. The introduction to playing cards. A standard deck of playing cards consists of 52 cards, among which there are 4 suites or groups. Okay, so there are 52 cards in a deck. They are divided into 4 equal groups. Now the 4 suits with their names and symbols and color are given here. The suits are diamonds, hearts, clubs, and spades. Alright, so the symbols are given here. Each of the suits have 13 cards in it. And one thing to note that is there are 26 cards which are red. So we see that the diamonds and the hearts are red and 26 cards who are black. Alright, so the clubs and spades are black. Now in each of the suits there are 13 cards and the type of the cards are like ace, 2, 3, 4, 5, 6, 7, 8, 9, 10 and jack, king, queen. Alright, so these are the 13 cards. So each of the suits will have these 13 different cards in them. Now you see that there are 9 cards in each of the suit who are numbered like 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 9 cards in each of the suits where the numbers are written. In each of the suits there will be 4 special cards named ace, jack, king, and queen. There's an example at the left side given for you to understand. So I hope you understand how many cards are there, how are they divided, what are the symbols, and what are the colors of the cards, and in each suit how the cards are named. Okay, now let's see our question. So our question 3 states that if you randomly choose a card from the deck of cards, what is the probability that it's a jack of hearts? Okay, so as you know that each of the suits will have a jack of its own, and so hearts will have only one jack. So jack of hearts is a unique card among these 52 cards. So what would be the probability of choosing the exact card which is jack of hearts from the deck? That is the question. It's pretty easy one. Question number 2 is the card has an even number on it. So you already know there are 9 numbered cards in each suit. So how many of them are even? You have to calculate that. Then you are going to finally get out the result. Question number 3 states that the card is of black color. So you've already seen how many black cards are there. So that is the number of elements in my expected event, and the number of total cards, which is 52, would be the number of elements in the sample space. So I just have solved this problem for you. Question number 4 asks you that the card is either red or an ace. So this is relatively a tricky question. So the card you have chosen, what is the probability that it's either red or an ace? So you have to determine how many red cards are there, and you also have to determine how many ace are there. And if you just simply add them together, will there be any overcount or not? You have to find it by yourself. So principle of inclusion and exclusion will help you solve this problem. Anyway, problem number 5 is what is the probability that the card is not numbered? This is simple. You know that how many numbered cards are there, so you can easily calculate how many are not. Then finally get the result. So the last question is again an optional challenge. The question asks you that what is the probability that the card you have picked randomly is a heart or numbered or a queen. Okay, so if it's a heart, it's okay. If it's numbered, then it's okay. Or if it's a queen, it's also okay. So what is the probability that this condition is satisfied? So the hints given here, you may use inclusion exclusion for 3 different sets or events in this case. Okay, so I hope you can solve the problem by yourself, and you must try to solve these problems because it would help you to prepare for our midterm. So have a great day.